In this problem, I'm going to write down what I know, and then I'm going to see what I can do to solve it. So we've got a code word here, at rest. When a penguin slides down the glacier starting from rest, that would mean that VI, let's see, get my right tool here. That would mean, there we go, VI, initial velocity is 0. Then it starts accelerating at a constant rate of 7.6 meters per second squared. I'm not sure it would really accelerate at a constant rate, but it makes the math a lot easier as we're learning this stuff. If it reaches the bottom of the hill going 15 meters per second, well, there's another velocity, and this would be our final velocity, would be 15 meters per second. How long does it take to get to the bottom? So I believe they're looking for a time. Time equals question mark. Well, from our definition of the acceleration, A equals VF minus VI, a change in speed over time. It looks like all the things I have over here would work in this equation. So I'm going to do a little algebra, rearrange it for t, which is just VF minus VI divided by A. Make sure all my units match. I've got meters per second, and 0 could be anything, so meters per second would be fine. So now I just do some math here. 15 minus 0 should label it. It's easy to get a little bit sloppy because you are in a hurry, but should really label everything. Meters per second squared. Okay, so now if I take meters per second in the top and I divide by meters per second squared, I'm just going to be left with inverted seconds on the bottom, which is the same thing as just plain old seconds. So I end up with t equals 1.97 seconds. Okay, and if you want to go back and look at that video about how many decimals and how many sig figs we should really expect in this, that's too many because we don't have that type of accuracy with the 7.6 number. That being the case, right around 2 seconds is what it's going to take the penguin to slide down the hill.